Good evening, everyone. This is Toshimasa Yamanaka from Japan is speaking. It should be around 8 o'clock in the evening, so I will start my talk from Japan. My topic is the introduction to the Kansei and Kansei research. Here, I'm sitting in my office. It is in Japan, of course, and close to Tokyo. And the Tsukuba is located up north from the Tokyo, the metropolitan Tokyo. And my school is located in the newly built Science City. This is my building, the school's building, my lab's building. It is the brand new. It's a kind of unique shape with the curved surface. And this is the lab. We are researching on the Kansei science in this lab. Okay, I'm gonna start the introducing what is the Kansei. Kansei is a peculiar term to Japan. It means the advanced function of the brain, which would be the source of emotion, inspiration, intuition, pleasure and displeasure, taste, curiosity, aesthetic, and creation. That has been declared by Akira Harada, my former professor, in 2003. The right-hand the picture shows, there's some kind of the pleasure, or everything is the field in your brain. So here how the diagram, how Kansei works. The originally we knows, we feels, the sensation, perception, and cognition, and memory and emotion are working together. So, for example, here is the black refrigerator, and the sensation will take this vision. Okay, noticed. Then we percept that this is black and cubic things. Then my experience or memory will cognize this should be the fridge. Okay, this is the fridge. But on the other hand, my emotion will working, activated by, since this is a kind of black refrigerator, so I'm automatically imagine that, oh yeah, I'm gonna move to the bar, excited. And when I like it, I will make purchases. So the physical things and the mental process, and then I pay a cash, or credit card. This is the returning to the physical world. So the Kansei process is more or less this green part, the perception and emotion and the reaction. All this the subliminal kind of process. We name this kind of process to be the Kansei process. Here is the history of the Kansei and Kansei research. History of Kansei as a research discipline. Now, from in the 17th century in Japan, there is the oldest written literature on the Kansei. And in 1957, Amane Nishi, and he's the philosopher or kind of the scientist, the traveler in the Netherlands, and he found a lot of the interesting science terms and translated into Japanese, and he made a translation of the sensitivity to Japanese word kansei. And half a century later, Amano Teiyu, he the philosopher, he translated the philosophical term Senskite to Japanese word to of the kansei. This is one of the very unique translation to the kansei from the Western terminology. In 1983, the Fujioka Wakao, he is the person of the advertising company. He used the kansei for describing the Japanese phenomenon of everybody is going to purchase things and exciting this kind of phenomenon. He introduced illustrate by using the term kansei. In 1986, Mitsuo Nakamachi, he is the originator of the kansei engineering, and in 1998, Akira Harada declared toward the kansei science. So this is the little long history. Then after recently, we established the kansei engineering working group 1993, and we had the 6th Asian Design International Conference in 2003, and that was held in my city, Tsukuba. We had more than 1,000 visitors from all over the world. And recently, in 2010, I organized actually the International Conference of Kansei Engineering and Emotion Research in Paris at the Paritech, Armature Paritech. So this is the historical background of the how we developed the kansei research. Kansei engineering and kansei process. What is the kansei engineering and kansei process? The kansei engineering is a translation system of the human kansei, and that's the kind of such a feeling or image, to the concrete or partial design. The researcher tried to approach with quantitative method to define properties based on human science, such as the color, shape, or function, and connection to human evaluation. This approach is named kansei engineering. So we use typically the semantic differential method to measuring the kansei and analyzing using the multivariate analysis or nonlinear analysis things. So the kansei engineering approach. Okay, here is the stimulus, and like I said before, sensory organ will capture this stimulus, and here like the other diagram, the physiological process and subconscious precognition system and cognition system will take that kind of signal. Then physiological response will get the physiological response, and the behavior will automatically behave with the subconscious things, and we can express how we feel. Then the kansei engineer try to connect the stimulus and the expression, but the kansei science tried to determine how our mental process is working in sense of the subconscious, or kind of using the behavioral analysis and the physiological analysis, of course expression. We mix together and find out what kind of the process in the mind we had when we noted like that, like before, and the black fridge, and how we feel admire the black fridge. Okay, the kansei research and mental model. Okay, here is the diagram: descriptive knowledge and tacit knowledge. Tacit knowledge is a kind of important, very important term in here, and we are thinking about the Kansei is acting to transforming tacit knowledge and descriptive knowledge, or the vice versa. No? Descriptive knowledge is the kind of base of the understanding, but the tacit knowledge, somehow we're using the tacit knowledge as the feels and directly express something. So, but when we learn things, our knowledge will based on the descriptive knowledge. No, the reading the book or the dictionary, then we get information by description. But somehow we transform that knowledge into the tacit level. Then the tacit knowledge will be used for the expressional conceptualization information. Among that, between that kind of process, we think about there is a kind we named the interesting process, mental process, as the evoked metaphor. This is the another way of saying the intuitive understanding. Now, understanding is not the reading, but the information evoked my metaphor. So this is the fundamental process of the communication, we think. So what Kansei design is? This is the example of the some sort of the concept design. This is a typical product design, although see, this furniture is a kind of hidden furniture from the flooring to the furniture will stand up from the floor. This is the folded to the only 1.5 centimeter thick. This is kind of showing how we smoothly feels. This is the we believe the Kansei, the designer's Kansei is working on designing this kind of the smooth or simple the design. Okay, this is another example. One piece of crayon. This crayon is mixed together all the color in one piece, and user will use this crayon, cropping and separating, breaking up the crayon, and find a right color they want. So this is the kind of the inspiring crayon for the creation. So this is another kind of the design example. Another one is called Gemini appreciation supporters. No? This is the robot. This is a robot. They are talking. They are mentioned to explain the art in the museum. But these robots will not explain directly to the visitor. They are browsing around in the museum. Then they talk. They are talking each other, just each other, not for the visitor. Visitor will notice it. This is an important point. Visitor will have to notice it. Then, curious about that. Curiosity will bring the understanding. Those kind of understanding is more creative and more close to the tacit knowledge, because this experience, this knowledge will stuck, got by people with experience. So this is our concept of the appreciation supporters by robot. Another example is the beacon. This is the cooperative musical instrument. This one is designed by the Toshimasa Yamanaka, my colleague, the young researcher. He designed this, and with the Kyoya Miho-san. She is now the designer at the Fujitsu Corporation. And this instrument is just a kind of musical instrument, detecting the position of the human, how far from the center. Then this machine will make sound according to this distance. Now the four beams are rotating, and each one beam cross the foot, then it makes sound. As many people gathered, then the different kind of sound can be made. Here, four people are working together to make sound. It's noisy so far, but when people understand the mechanism, then they can try to make a music with cooperation. This is the example of the cooperation. Jumping will skip the sound. Working and enjoying. Let's see. This is the creating music. Playing the music. Not only the foot will make the play the music, but also those kind of blick will play the music. So may become a new meaning of artistic expression. This is the concept-based research work and the design products. Okay. Next, I'm gonna present. It's a long talk. Sorry. I'm gonna present the concept research examples. This is the physiological index related to the concept process during appreciation of the artwork. Concept is a kind of intuitive process. So we try to find how different the reaction will be made by design trained people and design untrained people while watching the art. We measure the pupil size, change of the pupil size. Then find out the physiological with ANOVA. We found out the change of pupil size in starting 20 frames. That means 0.66 second of appreciation tend to representational art showing greater value. This means there are expansion tendency in the representation of the art. Abstract art or evaluator cannot understand. This index may correlate to the intuitive understanding of emotion such as puzzled or uninterested. So from this research, we are kind of thinking about the very short time at the beginning of watching the art. Our pupil size will change according to our interest. Okay, this is a kind of, and this is another kind of the interesting research process, the explaining and evaluating creativity with color arrangement task. And the color arrangement task evaluation using the NIROS technology. NIROS is the near-infrared spectroscopy. That is kind of the measuring device of the blood flow in the brain. Then this experiment is based on various tasks concerning three color arrangement. This kind of three color arrangement. The subjects were asked to arrange the three colors according to the instruction. Then we compared the design-trained people and untrained people. No, design untrained people used left left frontal cortex area, more in case of two-color arrangement task. It means that untrained people are more task sensitive in creating thinking. Such difference is not perceived for design-trained people. Design-trained people's brain function is very stable, but untrained people will have the special tendency shown on the only two-color arrangement task. Now this is the situation. This is the difference between the design-trained people and untrained people. Also, we tried out this kind of the major research on the building the Lego block, using the Lego block, model making, and we set up the two different kind of the task: color the building and white only, the monocolor building. So then, from this experiment and the combined together to the former experiment, results suggest that design untrained people use the right frontal cortex area more in case of the multicolor. However, design trained used some left frontal cortex more. So here we observe the design trained people and the untrained people difference between, in sense of the usage of the brain. So these are kind of the research work. Now, another research work I'm going to show is effects on the packaging, on the taste preference for your fruit juice. Fruit juice. No, there are two types of the image in the market. No, this is okay. It looks tasty, and the fruit juice with the fruit picture. Fruit juice with the cartoon. No, there are two different kinds. How the taste can different? We made an experiment. No, that apply the picture on top of the fruit juice, and to compare with that, we use the scrambled image, and we try to measure the difference between this scrambled image and the picture image, and also we try to compare between the picture image and picture image, cartoon image and the fruit picture image, and the result shows, the goodness of odor made show the great difference, the significant difference between the congruency or incongruency. Congruent image will the evoking the odor, but incongruent image will but the good image will evoking the freshness or artificially, those kind of things. So we are kind of feeling the taste, but the taste is not only one kind of things. So this kind of the research work shows the how our subconscious or intuitive process of the mind, that's what we say kansei, is working, and we try to apply this kind of knowledge to the design. Okay, so this is the gonna end of my long talk. That this is the process of the concept, illustrating sense, body, personality, mood, and behavior, creativity. Those kind of things are coming from the brain function. So then the Kansei engineering is born in Japan and successfully grown there. That is because our entire life is regarded upon the influence of Kansei. Kansei research became a new vector of the industrial development. Recently, Kansei research started to expand internationally with the link to design, emotion, sensibility. The multidisciplinary alliance of research will strengthen toward the development of a human-based new technology. Okay. Thank you very much. This is Toshimasa Yamanaka from Japan.